Hello everyone, my name is Revati and this is my MLP Kaggle assignment 1 submission. I have first imported NumPy and pandas and run this cell which was pre-existing to get the links for the train and test CSVs, and then I've done other necessary imports for pre-processing, splitting and tuning, that is in model selection and different kinds of models, as well as the metrics in order to compare the performance of the models. So we are first taking the train data frame and the test data frame using pandas.read CSV and the links that we have um, obtained from here. And then this is the first 5 rows of the train data frame. And now in order to perform prediction using a dummy regressor, we are first supposed to have the target column as price. So we are dividing this data frame into x and y. So in x we are dropping the price, and in y we are taking the price, and then we are fitting it on x and y. Over here in x test, I was not supposed to take the entire test data frame, but I was supposed to take the test data frame and dropping the column price, and then predicting based on that x test that I have obtained. So this was about the dummy regressor. And then we had data exploration part, in which we find that in the train data set there are 12 columns, which is also including the price, and 40,000 rows. So there are 40,000 samples and 12 features. One of the feature is the target feature, which is the price, which is an integer, whose data type is an integer. So as we can see, the id, which is a unique identifier, is also an integer, and most of them are objects with duration and days left to be float values. So we have the number of float values, integer values and object values as given as 2, 2 and 8 respectively. And then we are taking all the columns whose data type is object and getting the unique categories. So for a line we have 6 unique categories as well as their counts. For flights we have 869 unique categories. For the source city we have 6 unique categories. For departures 6 unique categories. Stops 3 unique categories, and arrival 6 unique categories. For destination we have 6 unique categories, and class 2 unique categories. Now we are going to perform descriptive statistics as part of the data exploration. So in this descriptive statistics we can use describe and then transpose it, so that for each of the column which is float or integer, we can find the descriptive statistics. For the numerical columns we can find the minimum, the maximum, the standard deviation, the mean, the median, which is 50%. This column named 50% is the median. And then we can also find the correlation using these numerical columns, and this is the correlation matrix. And we can see that most of the values are negative and the diagonal values are 1. There is only one correlation element with duration and price, that is positive. So they have a positive correlation between them. As duration increases, the price increases. So now we are going to deal with duplicates. So before dealing with duplicates, we are supposed to drop the id column, because if we do not, then when we perform this line, when we run this line, we'll get that there are no duplicate rows. So we'll get instead of 250 we'll get 0 over here, because IDs are unique always. So we are going to drop that column and take the data from without the ID, and then find the number of duplicates, and then drop those duplicates. So the shape that I now get is because I've dropped the ID, I get 11 columns and 39,750 rows. The next thing that we are going to deal with is missing values. So first of all, we are going to find all the missing values which are present, the count of missing values for each column, and then the total missing values in the entire data frame. And we are going to again deal with these missing values by using imputer, which will be coming under feature engineering later on. Then we have outliers. So we are splitting, we are just extracting the numerical features and the categorical features from this data frame by using select data types, and these are the numerical features. And in these numerical features, we are taking duration and days left, because price is the target feature, and then we are finding the outliers by finding the first quartile, the third quantile, taking the inter quartile range, finding the lower bound, the upper bound, and then finding whatever outliers there are which are lesser than the lower bound and greater than the upper bound. And then we are having the length of the outliers. So in duration we have 229 outliers, so it has more number of outliers, and duration in fact has a positive correlation with price, which is the target, so it's an important feature. So we are going to remove these outliers in the feature engineering section of this notebook. Now coming to visualization, I have used an histogram for the numerical features of duration, days left, and price, and then a bar graph which compares the number of trains based on the stops in each airline. So these are the airline names, and we have 3 different bars for each airline, which denote the number of stops, and the y-axis denotes the count of flights. And then we have a pie chart which describes the percentage of flights which describes the percentage of flights by each airline, and we can see that Vistara takes a significant amount of the percentage of flights. Next, coming to feature engineering, we are going to drop the outliers in the column duration, and then the remaining shape that we get is 39,521 rows. Now we are going to split into x and y by dropping the column price, and if we look at x dot head, the first 5 samples of head, we can see that there is no price column. And then in the flight, because these are all different values, we would want to make it into a category and then use it. So we are going to assign a label to the flights based on the number. So if their value is greater than 300, then we can just say that is a frequent flight. If it is between 300 and 100, then it's a seldom flight, and otherwise it's a rare flight. So for this column x of flight, we are going to apply this function flight labels, and now we have 3 different categories for flight, which is seldom, rare, and frequent, and their respective counts. Now coming to the pre-processing, there is an imputer in order to for the missing values, to deal with missing values which were present as seen in the missing values section of data exploration. Then there is an encoder, a scaler, and a pipeline. So in imputers, we are using mode, mean, and median as its strategies for different columns. So we are using mode, that is the most frequent strategy under simple imputer. For the columns of departure, airline, and stops, we are using mean for days left and median for the duration. And when we come to encoder, we are taking all the categorical columns and using one hot encoder for them. So the categorical columns are airline, source, destination, departure, stops, arrival, class, and flight. And then we are using a scaler for the numerical columns of days left and duration. And then we are using a pipeline with the steps of imputation and encoding as well as scaling. And then we are going to separate the data set into train and validation using train test split with a test size of 20%. So 20% of this train data frame that we were using, that is X over here, that we obtained over here, 20% of it will go into validation, and the remaining 80% is going to remain as X train. And then we can verify with the shapes. So X train and Y train has the same number of rows, that is what we have to verify. And X val and Y val, which are the validation features and labels, also have the same number of rows, that is samples. And then we are going to transform. So both the X train and X val are going to be fit and transformed using the pipeline. And this is the transformed data of X train. And now we are going to the section of model building. So first we are going to fit the model. So I've taken 7 models. So the first is linear regression, then k neighbors regressor with 5 neighbors, then SGD regressor and decision tree regressor, backing regressor, arbust regressor, and random forest regressor. So there are 7 of them in total. And then I have used in R2 score in order to find the score between the Y validation as well as the predicted ones using the models that we have fitted above. And these are the different R2 scores, and I visualized it in a plot, in a bar graph. And we can see that the backing regressor, decision tree regressor, and random forest regressor are the 3 models that give the highest R2 score. So we are going to use them, and let's do hyperparameter tuning to find the best parameters for these models. So for the random forest, we have parameters that we are tuning are number of estimators, maximum depth, minimum sample split, minimum sample leaf, and maximum features. For the bagging regressor, the parameters that we are tuning are number of estimators, maximum samples, maximum features, and bootstrap. For the decision tree regressor, we are using max depth, minimum sample split, minimum sample leaf, and max features. And then using a randomized search CV, each with cross validation CV of 5 and iterations, 10 iterations, and these are the best params that we have obtained. Now using these best params, we are we are finding out the R2 score. And if we visualize the R2 score, we can see that the bagging regressor is slightly better than the rest. And so we are taking test data frame, which we already imported at the start. If we look at over here, then using this link, we have already taken the test data frame. So we are using that test data frame back again over here. So and then we are taking X test because we are taking it without ID. First we are dropping the ID, and then we are again applying flight labels function to the flight column of the test data frame, and then transforming it using the pipeline. And this is the first 2 columns of the test data set that we have obtained. And then we are using this bagging regressor that we have selected and fine tuned to predict them and submitted it. So this was all about my Kaggle assignment submission. Thank you.